Okay, good afternoon, everyone. Just checking, can you hear me okay? Super, okay. Well, firstly, thank you for attending this session on Hinkley Point C. I know you have so many opportunities to go elsewhere, so I feel very privileged that you've decided to join me here today. Thank you very much. So I'm Tam Al-Bishawi. I'm the Chief Nuclear Officer at Hinkley Point C, which means I'm responsible for commissioning and future operations. So a huge privilege for me. My background is operational, so I've been in the nuclear industry for 20 years, operating power stations around the UK. So I was at Torness in Scotland, which is 2 gas reactors, where I was the site director. And then I was at Sizewell B, and I was also at Heysham 1 power station. All gas reactors except Sizewell B. So I have a little bit of understanding of water reactors, which is very useful for Hinkley Point C. So a bit like Hinkley Point C, I was trying to do something special today. I was going to get you all to do a quiz, a very special quiz. But like Hinkley Point C, when you do things for the first time, sometimes they don't go to plan. And what you have to do is you have to adapt. So I've adapted. The quiz is not going to work for security reasons, but I'm going to do a different type of quiz that will enable us to interact a little bit just to get your thoughts. Okay, if you're ready. So this was the original quiz. We're not going to do that, so we're going to use the backup. So just a few questions for you. I'm interested in what you think. So low carbon energy to how many homes? When Hinkley Point C is operational, how many homes will we provide low carbon energy for? 6 million. Straight up, perfect answer. That's correct. Thank you very much. Okay, how many job opportunities will Hinkley Point C create? Oh, okay. Did I pay you to know the answers? The answer was 25,000, and again, that would be correct. Okay, so the record is very, very high, so the next answer has to be correct. Length of all HPC's electrical cabling. What's the length in to the nearest 1,000 kilometer? Everyone's a bit nervous now because the results were so good. 26,000. Okay, thank you for being the first to speak on that one. Who else wants to have a go? Go on, someone. Less than 26,000 is the answer. 25,000. Thank you, Paul, for attempting. So it's 9,000 kilometers. So 9,000 kilometers. Quite a lot of cable. And how much more steel is used at Hinkley Point C compared to Flamanville? Anyone want to guess? In percentage? 20%. Good guess. Close. 20%. Maybe while you're thinking, I'll explain the reason. The reason is with the different regulator, there's different requirements in terms of reinforcement and some slight design changes. In fact, I would classify Hinkley Point C as a first of a kind because there's about 25% difference in design. But the steel, your answer was 20. Any other takers? So 20 was the first answer. 25 is much closer, so it's 35%. 35%. So more steel. And how much more concrete will HPC use in construction? Percent will be fine. Anyone know? 50? 50%? It's a bit lower. It's about 24%. So about 24%. Thank you for engaging. So it is different, isn't it? Hinkley Point C is different. And, you know, different comes with some challenges, but some huge opportunities as well. Okay. So this is what Hinkley Point C will look like. I'm very much looking forward to it when it's an operational power station, where I feel a bit more comfortable because that's my experience, that's my background, and we'll be making electricity and sending it out. So beautiful looking plant, and there'll be a nice walk. Don't know if I've got a laser. There'll be a nice walk here where I plan to walk with the team every now and then, get some fresh air. But it's a very long walk because Hinkley Point C is very big, much bigger than my old stations. Okay, so construction began in 2016, but the first concrete was 2019, and it's 2 1.6 gigawatt EPRs. Will produce 7% of UK electricity. And you can see the answers on some of the questions. I would consider it a first of a kind as well. Okay, a little bit about Britain in general. I worked at a lot of these power stations, so I can share this. So the state in the UK, we're expecting a lot of our nuclear generation, all apart from one, to be shut down in within the next 10 years, probably before. The only one that will be operational is Sizewell B power station. So you can see there's a real compelling reason for Hinkley Point C to be constructed and to be operational. So when all these stations shut down, we'll have Hinkley Point C and Sizewell B, and together, Hinkley Point C and Sizewell B will be able to generate as much as we're generating today with all the nuclear reactors in Britain because of the size of Hinkley Point C. And Hinkley Point C, we consider it number 5 and 6 of the EPR family, Okiloto 3, Flamanville 3, and Taishan 1 and 2. And it's hugely beneficial to come a bit later in that sequence, hugely beneficial because we can take a lot of learning, but also we know Hinkley Point C has some differences. So lots of learning for us to take, but some things that we're facing for the very first time as we build Hinkley Point C. And just something about, I'm going to talk about the delivery model in a little while, but something about the way Hinkley Point C works. I joined Hinkley Point C 2 years ago from my previous roles. And Hinkley Point C, there are over 11,000 people there now. There are so many suppliers and partners, and we are essentially the customer, but we have to be a very intrusive customer. So we have to be involved in pretty much everything. And that can be quite challenging when you have different suppliers from all over the world with different standards, with different ways of working. To be able to ensure there's a common standard, a common way of working is very challenging. And that's why we created a delivery model, which I'll talk about. So when we embarked on Hinkley Point C in the UK, one of the things that's worth noting is the last power station built was Sizewell B. And the last time we built a power station is when we had the infrastructure to build power stations. But since then, we've been quite quiet when it comes to nuclear new build, which means we didn't have, and in fact, we are still developing the capability to build and operate this large power station in the future. So you see the numbers there. You should see at 30,000 training roles for welders, mechanics, electricians. So quite a lot are actually going through that training phase for Hinkley Point C. It's not just going to benefit Hinkley Point C, clearly, because once these individuals are trained, they have that capability, and they will have practiced it at Hinkley Point C, which means, in my simple mind, when I build something at home, the first time I build it, like an IKEA bit of furniture, I'm a bit slower. When I build the second one, I'm a bit faster. Not because I'm using a process, just because I've just done it. So actually, I think doing this will really help for the future, for example, for Sizewell C and beyond, by training more people and building that capability. Now, I'm not going to lie, it is one of our biggest challenges. Having the right resources is one of our biggest challenges. When you talk about 11,000 people working at Hinkley Point C, one of our challenges was to get enough welders, and we looked all over Britain, and we took all the welders in Britain. Still wasn't enough. And that's the truth. It was not enough. So there is a challenge in terms of creating that resource and capability. So very positive, and my hope and my confidence is this will help in the future as well. So the supply chain. It's interesting because I heard a few talks today about the supply chain. And I think we are all across the globe facing some challenges and opportunities with the supply chain. So the Hinkley Point C, as I mentioned, is very dependent on suppliers. Our focus is to really strengthen and grow the UK supply chain to be able to build more nuclear power stations in Britain. And a positive shout to France. France is our where our primary suppliers come from. So 36% of our suppliers are from France. So thank you for that. And we're in France today, so another bit of recognition. Thank you very much for that. And a lot of our companies, both Tier 1 and Tier 2s, are coming from Europe. And in fact, some companies were created with the confidence that Hinkley Point C is progressing. It's a very large project with huge opportunities. And it's great to see some of those companies thriving now, actually out with Hinkley Point C. So they were set up for Hinkley Point C, but then they grew, succeeded, and now are thriving also out with Hinkley Point C. So just a few figures I'd like to share. 64% of the value of HPC will be with UK-based businesses. So it makes it very attractive as a business model when we're able to use the majority for the UK businesses. Okay, you can see a picture there of the rotor. I will show you a video in a minute, but before the video, you have to endure me for a little bit. Okay, Hinkley Point C progress. There's already today, every person I bumped into, pretty much, when they saw my badge and they saw that I work at Hinkley Point C, asked me, how's it going? How's it going? How's it going really? How's it going? So I'm going to tell you how it's going. I'm going to tell you it first in personal terms. So personal terms, I go on the plant every week. I walk around the plant every week. So I'm going to be, in the future, I'm going to be running this plant. So I really like to see things that I'm never going to be able to see again. It's going to be all underground probably in a year's time. So when I walk around the plant, I'm going to tell you the truth here. I go around 1 week, and then I go and take the same route the next week. What happens? It progresses. I can't take the route because there's a building in front of me. So I go around the route and there's a wall or there's a door or there's a barrier. And it's hard to quantify that, but that shows me progress. You know, it's real progress. Things are changing every week. I have to take a different route. I have to plan my route every week. So I think it's really positive how it's going. Now, we have some milestones that we measure. And one of them is really, really important, which is putting the dome on. It's not important in terms of the schedule, in fact. It's not critical in terms of the schedule, but it's really important when you see the dome on top of reactor 1. It's like it's like putting the lid. It's like a complete structure. So when my team, part of my team are the future operators, when they see the lid on top, I think they get a bit more excited. I know I would. When the lid's on top. The lid's going to go on in the next 2 weeks. The lid will go on before Christmas. Everything is being progressed so that the lid goes on before Christmas. And when we have the dome on top of Unit 1, the changes. You know, the skyline will change. You'll be able to see this big dome on top of Unit 1. So that's a really, really powerful milestone that's happening in the next 2 weeks. And we will produce a video. You'll be able to see it on YouTube. Once we've put the dome on, there will be a video that we're going to share so you can see how the dome goes on. The main control room lift, at the time I did the presentation or we prepared it, the main control room was not lifted. Now it's in place. We have lifted the main control room. It's in place. That's where the future operators will sit and operate and control the plant. That's where I started my life. I spent 8 years in shift in a control room. So I have a very warm feeling. Now, the control room doesn't look as welcoming yet because it's just a big box at the moment. But it's a big box, it's in place, and now we're going to fit everything else around it, including the cables and the instruments, etc. The turbine hall, completing the turbine hall, that's progressing well, but it won't be complete this year. That was one of our targets, was to complete the turbine hall this year. It'll be completed early next year. So that's progressing very well. Again, it looks different. You look at the turbine hall in Unit 1, you can see a turbine hall. You know, if you've been into operational stations, you can see the structure, you can see the foundations, you can see where the turbine's going to go, you can see where all the motors and the pumps are going to go. So it looks real. We just have to make sure we put some cladding and covers on just to finish the turbine hall and allow GE, one of our main partners, to come in, General Electric, to come in and essentially progress the installation of the turbine hall. And progressing the fuel building is ongoing. So today, what would you see? I mean, have any of you been to Hinkley Point C? Yes, that's why you know all the answers? Yes? Yeah, quite a few. Okay, some of you work there, I know you, so you don't have to raise your hands. So from today, what you would see is, you would see out of the 11,000 people, about 6,000 are civils. So most of the people at the moment, most of the work scope is civil work. So next year is a really interesting year, because next year what happens is there's going to be a shift from civil being the primary activity to what's the next phase? MEH, mechanical, electrical, HVAC. It's already happening, it's kicked off, but it's a very interesting time, and we've learned from the other EPRs that it's a critical time to get right. How do MEH come and work while civils are still working? How do MEH install while some of the commissioning team, some of my team, will be commissioning? Who's in charge? Under which safety standards do we work? Who owns the risk assessment? There's a lot of questions. And actually, we're very lucky that the other EPRs have shared very openly with us some of these challenges. And we've taken that on board in how we've written our processes. And now we have a very collaborative model, which I'll talk about in terms of how we deliver work. So MEH will pick up quite heavily next year. We'll expect to see our staff, the number of people working on site, go up to about 12,500 people, which was not the original plan, but actually we have a lot of work to do, so we're going to increase the number of people. And we've been quite successful in developing and attracting people from around the world, as well as in developing people in Britain. So we're going to use that additional capability. Okay, the polar crane I'm going to cover in a minute. I'm going to actually show you a picture of the polar crane. I walked it down last week. The polar crane, before we put the lid on, before we put the dome on, really we want to put the crane in from the top because it's very big. If any of you have been to the EDF stand, you're able to use virtual reality. I did this morning, by the way, to see Flamanville 3. So when you do that, look carefully, you'll see, you don't have to look carefully because it's huge, you'll see the polar crane. I was very keen to see it in position because the polar crane at Hinkley is it's in a big tent at the moment, being finalized before we lift it and put it in the permanent location in the reactor. So it's in a purpose-built tent that keeps it safe and preserved while we finish the bolts and the fasteners before we lift it into final position. Okay, I'm going to move us forward. So yes, the overall progress, we are 60% complete overall. And we have a very ambitious schedule. We have a very ambitious schedule, especially being the first of a kind. But you know, it's great for driving people to be creative and really consider that a lot of things won't work the first time. So we have to be ready and have the backup ready, just like we did with our quiz. You know, that's what we're doing. That's what we're doing at Hinkley Point C. We're getting better at it. Are we perfect? Absolutely not. Have we got some benefits? Yes, because we've had some really good operating experience from the other EPRs. And our 96-month schedule is what we're working to, but there are some challenges to that, is the truth, and we're working through them as best as we can to minimize any delays. Okay, I'm going to show you a video. Let's hope the audio works okay. Are you ready? Okay, this is the latest video. It's a few months old, but things haven't... You'll see the next one with the dome on probably in a couple of months. Things haven't changed at the top level too much.
Welcome to Hinkley Point C, where we're building Britain's first nuclear power station in more than 30 years. Night and day, it'll power 6 million homes and will be crucial in helping us achieve net zero and stronger energy security. Right now, we're busy working towards a really big milestone in the project's construction. Let's go and find out more. Welcome to the heart of the first reactor building. The teams are getting ready to lift the 245-ton steel dome on top of the building. It will be a spectacular sight and a significant milestone for the project. Below me, we have installed the support ring, which will hold the reactor in place. The reactor arrived on site early this year and will be installed next year. You can see we poured the concrete around the big prefabricated pool, which will be home to the reactor for its operational life. Next, we'll fit the huge equipment hatch, which will be installed on this opening behind me. It will open and close, allowing equipment to be moved into the reactor building during construction and operation. In the coming months, we'll put the polar crane on the brackets which are being prepared above me. It's a huge rotating crane that will sit under the dome. It's under construction here on site and will be lifted in one giant piece. All these elements have to be completed before we can lift the dome, which is just over there. Good morning. We're here at the dome, where we're making the final preparations before the dome will be lifted into place later this year. Let's go and take a look. Wow, look around. We're now under the dome itself. We've spent a lot of time working on the steel structure, carrying out the manufacturing, welding, coating, and services installation and testing. And in just a few months, it'll be lifted on top of Unit 1 by Big Carl, the world's largest land-based crane. There's a real sense of anticipation and excitement, and we've been building for this moment since the project began. Once the dome is lifted, the first reactor building will be weatherproof, so our mechanical and electrical teams can really get to work on installing the pipes, the equipment, and the cables. We'll also start introducing the big nuclear components, like our steam generators, which have finished initial testing at Framatome in France. Now, all these components need to be controlled from one central point. And that central point is our main control room, and it will be installed right here on this concrete slab. We're busily finishing the walls that will sit around the main control room, but it won't be long before it'll look just like this. Our trainee reactor operators are already using the simulator, which is an exact replica of what the control room will eventually look like. The actual control room is on the other side of the site and will be lifted to where I'm standing before Christmas and then fitted out. It will control the reactor building and also the power generation in the turbine hall. Unit 1's turbine hall is really taking shape. Right here, we'll install the world's largest steam turbine, the Arabelle, made by our colleagues at General Electric. The turbine will generate electricity using steam generated from the heat in the reactors. These huge white structures above my head are the roof trusses, taking the hall to its full 50-metre height. We're now gearing up to install the 300-ton crane. It's under construction in Avonmouth and will be used to install and maintain the equipment in the turbine hall. So that's above ground. Now let's go underground. I'm now on my way out to the end of the tunnel, which will return water to the Bristol Channel, more than a mile out to sea. It's big enough to take a train and is one of 3 tunnels which will circulate our cooling water. I'm right at the end of the outfall tunnel, where 23 metres above us, 2 huge jacket vessels are drilling down through the seabed. This summer, they installed 6 giant steel casings to form shafts. We'll join it with the tunnels down here, and we'll dig out to make the connection. It's some of the most complex work in our entire project. Back here on shore, the pump house is progressing really well. Civil works are now 2/3 complete, and the mechanical and electrical works are underway. Now let's go and check out one of my favourite views of the site. From here you have a great view of Unit 2, our second reactor. After slowing down during the pandemic, work is progressing well here, particularly on the concrete inner and outer containment structures on the reactor building. And it means we'll be ready to install the second steel inner ring later this year. Construction of the whole of Unit 2 and its systems is really benefiting from the lessons learned over at Unit 1. Many tasks are achieved in 20 to 30% less time than on Unit 1. That replication principle underpins our plans to build an identical power station at Sizewell in Suffolk. And that's it for our latest tour. I am so proud of the people working here on site and the thousands of people working on this project right across the world. Next time you're here, the dome will be on Unit 1 and the site will have transformed again. More of our mechanical and electrical work will be underway, and we'll be installing and testing more equipment so that it's ready when the power station becomes operational. See you then. Thank you.
Okay, hope you enjoyed that. Some of you may have seen it before, but I've seen it so many times, and I still really enjoy it. The next version, like I say, will be out soon. Okay, so project delivery model. Now, I am conscious of the time. I understand after this, I will be in there, so if you have any questions, we'll be able to do it. I'm going to speed up a little bit because I think I had too much fun in the first bit. So, delivery model. Like I mentioned at the beginning, with Hinkley Point C, we have so many different partners and suppliers. And we're having to utilize, really, the expertise from all over the world. We have a design that is different. It is different. You know, fundamentally, it's similar to the Taishan and Flamanville. However, we have made some changes, including a separate INC system as the biggest one. And with a project of this size, we have to be efficient. We've had a lot of OPEX on the importance of how we deliver work. Lots of operating experience that this can really make or break a project. So we need a delivery model that's agile, that allows us to be consistent, that allows different partners and suppliers to be able to walk in and know where they fit and what they need to do. And ultimately, we need control. You know, we need some form of control with a very complex organization with so many different partners and suppliers and a very high consistent standard expected. We need control. So I'm going to jump us on to what the delivery model looks like and how we've implemented it. Now, I should say, before I was CNO, I was part of the delivery directorate. So I was part of the team that used this model. So I can give you my, my view on it and some practical examples, if we have time, that I was involved in on how the delivery model works. I think it works really well, actually. I think it does work. Okay, so don't worry about the text. I'm going to just jump through and talk to you about a few things. So we have a process just to make sure that we are consistent and clear. We have something that sets the overall governance and direction. But the key one I want to focus on is this. So to achieve a really straightforward delivery model, what we needed people to be in charge. We have so many different programs, including civil, MEH, INC, commissioning, and other programs, digital. But we wanted the people, a specific area to be responsible and accountable. And that's why you saw Simon Parsons before. So Simon is the nuclear island, it's not working very well. Simon is the nuclear island area director. That means anything in the nuclear island is in his area, in his decision-making, in his accountability, in his responsibility. So for example, if Simon wants a certain civil structure done at a certain time, for example, to install the polar crane that he talked about, we need a certain structure in place. Simon would go to the civil team, the civil director, and say, this is when I need the civil structure done to this standard. So the concept is the area directorate, so each area, will be able to pull on and essentially require the support that they define from all the other programs and areas. So essentially one person ultimately is accountable for the delivery of the scope in that area, and everyone is the transverse side. So like civils, MEH, INC are supporting that delivery. Okay? So it's the area model. We have actually adapted it a little bit since this slide, but the principle is exactly the same. So we have area directorate, and the transverse teams support the area. And just as an example, again, I know this is small. This is more to just illustrate the process of how we deliver work and get work done. So if you think about it from the civil stage into the construction, starting from the design stage into the detailed design, into the construction, and then into the installation, you come back to this area model where even in the design stage, we had an example where we know things don't always go to plan. When they go to plan, any process will work. But when things don't go to plan, like a bit of kit that we received wasn't meeting the design requirement. So the technical director, the technical team, identified a gap. because they're part of the customer, part of the client. And the technical team then went to the area responsible. So in the case of this kit, it was the nuclear island, and said, this doesn't meet the requirement. The area then said, okay, tell me how we can make it meet the requirement. And then we went back to the designer in France, in fact, who helped us identify what we need to do to make this bit of kit meet the requirement, at what time scale it's required. So it was all driven by the area team. And we had this transverse support through the technical team. The technical team essentially checked what the, okay, I've got 3 minutes to go, checked what the designer has come up with. Okay, I'm going to move us forward because of time. And I'm going to talk about what underpins our delivery model. What underpins it? Again, you've probably seen a lot of stands about digital. So if you imagine a world, if you're like me, you've worked with procedures, documents, hard documents all your life. That's what I've done. And then you go to a data-centric world where instead of having a procedure that tells you what to do, you have the data into a big database that's very intelligent, that is able to adapt based on your progress. So in the good old days when I was operating power stations, I have a procedure, I do a test, and then something happens that I have to do differently. Or someone calls me for a higher priority job. I have to go back and restart from where I was, check where I was in the procedure. Well, in commissioning, in operations, in construction, things don't go to plan. You have to adapt. Having a data-centric approach allows us to be more agile because you update the data and then the tool tells you what bits are outstanding. So it's not go through a bunch of procedures, reread the procedure, make mistakes. That's when mistakes are made, when things don't go exactly to plan. So this data-centric approach I would love to talk about it more, but maybe we can do it in the Q&A, is really, really powerful. There is a problem. Not all suppliers are data-centric at the moment. That's just the world we live in, you know. We have to encourage that data-centric approach. And for some people, it's hard. It's very hard to do and costly. But that's the principle of our digital tools that will help us going forward. I'm really excited about the digital tools. I think they're going to reduce error and we're going to be much more efficient when they are embedded across all our partners. Okay, 3D modeling, again, from the operating experience, there were some issues in construction of all the EPRs, as there are with all the other nuclear power stations. And one of them was these conflicts of physical conflicts where a bit of pipe or a bit of support is hitting something else. It sounds basic, but with a very complex power station, it's very easy to have a bunch of clashes. I see a few people nodding. It does happen quite a lot. So the 3D model, our teams are able to take a tablet with them when they're out, and they're able to see what it's going to look like, what's going to clash with what, and it reduces the likelihood of rework, the need to redo things and reassess things. Okay, I'm going to skip this for time. So here, I'm just going to bring out one point. I gave the example on the polar crane on a bit of kit in Nuclear Island where things weren't exactly as we expected and how we fixed it. But the key bit is we have the engineering or the technical team. We have a joint design office which has embedded people from the design team, from the French designer, embedded there to have this agile response. So imagine, you know, I know the power of distance. If people are far away, it tends to be a bit less efficient. So actually having the joint design office on site with the designers, who are generally based in France, embedded is quite powerful. Okay, I'm going to finish with a picture of the polar crane and just recognition of the efficiencies gained from Unit 1 to Unit 2. So you can see a few examples here, but on average, between 30 and 40% more efficient with Unit 2 construction versus Unit 1. And I spoke to some of the people that did this. It's very natural. It's instinct. People learn things and adapt things and how they do work. So that's very positive. Imagine if we take that further into Sizewell C, Unit 1 and 2. It'd be great. Okay, a few things about modularization, which we learned from Flamanville and Okiloto. And I'm going to stop there. Thank you very much for your attention, and thanks for the input. Cheers. Thank you.